Hi, I'm Alex, Dr. Tam's friendly AI teaching assistant. So today, we are going to talk about geometric optics. In this section of the course, we're going to learn about things like the laws of reflection, the law of refraction, how images form with mirrors and lenses, and we'll even learn about some real-world applications that use these concepts. So let's get into it. Okay, so here are the learning objectives for today. By the end of the lesson, you should be able to define the laws of reflection and refraction with 100% accuracy. You should also be able to calculate the angle of refraction using something called Snell's law. You should be able to illustrate how images form using mirrors and lenses. You should be able to solve at least two real-world problems involving image formation, lenses and mirrors, and you should be able to evaluate the effects of varying indices of refraction on light's behavior in a given problem. And lastly, you should be able to predict the outcome of light's interaction with a surface or medium based on what we learn in class. Alright, now that we know what we're getting into, let's go ahead and get started. Alright, so to start off, I just want to review the law of reflection. So here we have an example of the law of reflection. We have a light ray that is hitting a surface, and notice how the angle of incidence is equal to the angle of reflection. The angle of incidence being the angle between the incident ray and the normal, which is a line that is perpendicular to the surface at the point of incidence. And then the angle of reflection is the angle between the reflected ray and the normal. So again, the law of reflection states that the angle of incidence is equal to the angle of reflection. Now we can use the law of reflection to solve for the angle of reflection in this diagram. So if the angle of incidence is 30 degrees, what is the angle of reflection? Well, according to the law of reflection, the angle of reflection is also 30 degrees. Alright, now let's move on to the law of refraction. In this diagram, we have a similar situation, except now we have a ray of light that is traveling from one medium to another, from air to glass, and we have the angle of incidence, and we are looking for the angle of refraction. Now the angle of refraction is defined as the angle between the refracted ray and the normal. So the first step is to draw the normal. Now we can see that the angle of incidence is 30 degrees, but now we need to find the angle of refraction. To do that, we're going to use something called Snell's law. So Snell's law states that the ratio of the sine of the angle of incidence to the angle of refraction is equal to the ratio of the indices of refraction of the two media. So if we know the indices of refraction of the two media and the angle of incidence, we can use this equation to solve for the angle of refraction. So in this case, the index of refraction of air is approximately 1 and the index of refraction of glass is approximately 1.5. So we can plug these values into the equation along with the angle of incidence of 30 degrees and solve for the angle of refraction. Okay, so I'm going to leave this problem up for you to work on. If you're not sure how to solve for the angle of refraction, go ahead and pause the video and try to work on the problem. If you get the correct answer, go ahead and post your solution in the comments section, and if you get the wrong answer, don't worry about it because I'm going to show you the correct answer right now. Okay. So the correct answer is that the angle of refraction is approximately 19.5 degrees. So once you have the angle of refraction, you can draw the refracted ray and you lines. Notice that the angle of refraction is indeed approximately 19.5 degrees. Okay, now that we have the laws of reflection and refraction down, let's move on to how images form using mirrors and lenses. Okay, so here we have a concave mirror and we have a light ray that is hitting the mirror. The light ray will be reflected, and we'll see that the reflected rays are diverging. Now if we extend these reflected rays, they will appear to intersect at a point, and that point is called the focal point. Now if we take an object and place it at the focal point, we see that the reflected rays will form an image of the object on the other side of the mirror. So this is a real image because it is formed by the actual intersection of the reflected rays. Now we can change the position of the object and we see that the position of the image changes as well. If we move the object closer to the mirror, the image will move closer to the mirror. And if we move the object farther away from the mirror, the image will move farther away from the mirror. Okay, now let's move on to real-life application. Okay, so here we have a real-life application of the concave mirror. We have a spoon in a bowl of soup, and we can see at the handle of the spoon is closer to the mirror than the bowl of the spoon. This means that the bowl of the soup is closer to the focal point of the mirror and the handle of the spoon is farther away from the focal point of the mirror. Since the bowl of the soup is closer to the focal point, the image of the bowl is formed closer to the mirror than the image of the handle. This is why we can see the handle of the spoon behind the bowl of the soup. Okay, now let's move on to lenses. Okay, so here we have a convex lens and we have a light ray that is hitting the lens. The light ray will be refracted, and we'll see that the refracted rays are converging. Now if we extend these refracted rays, they will appear to intersect at a point, and that point is called the focal point. Now if we take an object and place it at the focal point, we see that the refracted rays will form an image of the object on the other side of the lens. So this is a real image because it is formed by the actual intersection of the refracted rays. Alright, now if you would like to review more concepts related to this lesson, then you should definitely check out the next lesson. Hey, I'm here from my channel, and today we're going to be talking about geometric optics. Specifically, there are 6 things that you need to know if you want to master this topic. By the end of this video, you should be able to define the laws of reflection and refraction with 100% accuracy. So let's go ahead and get started. The first thing you need to know is the law of reflection, which states that the angle of incidence always equals the angle of reflection. Now, the angle of incidence is the angle between the incident ray and the normal line, which is a line that is perpendicular to the surface at the point of incidence. The angle of reflection is the angle between the reflected ray and the normal line. And so since these two angles are equal, the law of reflection is satisfied. Now, the second thing you need to know is how to calculate the angle of refraction. We can use something called Snell's law, which states that n1 times sine of the angle of incidence always equals n2 times the sine of the angle of refraction. So this equation is pretty simple to use. All you have to do is plug in the known values and solve for the unknown. The third thing you need to know is how to illustrate the formation of an image using mirrors. In particular, you need to know how to do this for both concave and convex mirrors. For example, in this scenario, we have an object and we want to find where the image is formed. To do this, we use the mirror equation, which is 1 over the focal length plus 1 over the object distance equals 1 over the image distance. Once we have the image distance, we can use the magnification equation to find the height of the image. The fourth thing you need to know is how to solve real-life problems involving the formation of images, lenses, and mirrors. For example, in this problem, we have a lens and we want to find the location of the image. To do this, we can use the thin lens equation, which is 1 over the focal length equals 1 over the object distance plus 1 over the image distance. Once we have the image distance, we can use the magnification equation to find the height of the image. The fifth thing you need to know is how to evaluate the effects of varying indices of refraction on light behavior. In particular, you need to know how to do this when light passes from one medium to another and when light is reflected or refracted by a surface. For example, in this problem, we have a beam of light passing from air into water. We can use Snell's law to find the angle of refraction. Then we can use the law of reflection to find the angle of incidence. The sixth thing you need to know is how to predict the outcomes of light's interaction with surfaces and media based on what you have previously learned. This means that you should be able to predict what happens to light when it is reflected, refracted, or when it passes through a lens or a prism. For example, in this problem, we have a beam of light passing through a prism. We can use Snell's law to find the angle of refraction for each interface. Then we can use the law of reflection to find the angle of incidence for each interface. Alright, now that you know what you need to know, let's go ahead and practice these concepts so that you can master them. Alright, now that you've had some time to practice, let's go ahead and check your answers. Okay, so you should have defined the laws of reflection and refraction with 100% accuracy. You should also be able to calculate the angle of refraction using Snell's law for at least 3 different scenarios. You should also be able to illustrate the formation of images using mirrors and lenses, including at least one real-life application within 30 minutes of practice. And you should be able to solve at least 2 real-world problems involving image formation by lenses and mirrors. You should also be able to evaluate the effects of varying indices of refraction on light behavior in a given problem within a structured framework. And you should be able to predict the outcomes of light's interaction with surfaces and media based on what you have previously learned. Alright, thanks for watching. If you enjoyed this video, please consider liking and subscribing.